block elements, group 15. Group 15 elements are otherwise known as pnictogens. On writing the configuration, one is able to understand that the valence electrons are 5 in number and that will be filled in the s and the p orbitals, due to which the general electronic configuration becomes ns2 np3. The first two members are non-metals, that is nitrogen and phosphorus. They have non-metallic behavior. Arsenic, antimony, they are semi-metals or metalloids, whereas the heavier members bismuth and ununpentium or moscovium exhibit metallic behavior. The first member, nitrogen, exhibits a different behavior from the rest of the members, and that is known as anomalous behavior. You find that this anomalous behavior occurs due to small size, high electronegativity, high ionization enthalpy, and absence of d orbitals. In addition to that, nitrogen also has the capability to form p-pi multiple bonds, and it's restricting its covalency only to 4. On comparison with group 14, you find that group 15 elements are having small sizes in their atoms, and due to which you find that ionization enthalpy is considerably high. In addition to that, you find that the p orbitals are half filled in these elements, due to which they have high values for ionization enthalpy. Coming to the next 2 points, that is electron gain enthalpy and electronegativity. When the size of the atom decreases, electron gain enthalpy becomes higher, that is, it becomes more negative. And when we are checking the electronegativities, you find that electronegativity also increases with decrease in size. So down the group, you find the electronegativity generally decreases, whereas electropositivity increases. However, the first element, nitrogen, will show a lower value than expected for electron gain enthalpy, and that is because the incoming electron will be facing repulsions from the lone pairs present on nitrogen atom. Coming to atomic and ionic radii, you find in a group, you find the size keeps on increasing because of extra number of electrons present in the different orbitals. This change is visible from nitrogen to phosphorus considerably, but from arsenic to bismuth, you find the sizes are not increasing in a gradual manner. This occurs because of the filling of the d and f orbitals, which are having poor shielding effect. Next is ionization enthalpy. Ionization enthalpy is dependent on the sizes. When the size increase, ionization enthalpy also should decrease. But because of the extra stability of half-filled p orbitals, you find that the ionization enthalpy of group 15 elements are found to be higher than what is expected. And you find that down the group, ionization enthalpy is found to decrease. Next is electronegativity. We have learned that electronegative atoms will be small in size. So when the sizes are small, it have a tendency to attract a shared pair of electron more towards it, due to which nitrogen becomes the most electronegative element in the group. Coming to the physical properties of group 15. All the elements in the group are polyatomic. Except for nitrogen, all others exist in the solid state. You find nitrogen always exists in the diatomic state due to the anomalous behavior, it is capable of forming triple bond among the different nitrogen atoms, and it has high stability owing to high bond dissociation enthalpy. The value is found to be 941.4 kilojoules per mole. Phosphorus, on the other hand, exists as P4. The rest of the members are also polyatomic. You find that down the group the metallic behavior increases as the atomic size increases, and there is a decrease in the ionization enthalpy. Coming to the boiling points, you find that boiling points generally increases down the group. But when we check the melting points, it increases up to arsenic and then decreases. Except for nitrogen, all other elements exhibit allotropy. What do you mean by allotropy? The same element can exist in more than one stable form, and that is possible mainly for phosphorus. Phosphorus is found in 3 different varieties: white phosphorus, red phosphorus, and black phosphorus, which we will be dealing with in the next PowerPoint. Now coming to chemical properties. So in order to understand the chemical reactions, first we must understand that these group 15 elements are somewhat reactive. And why it becomes reactive? Because only 5 valence electrons are present. So how do you understand that there are 5 valence electrons? That can be got from the group number. So if you subtract 10 from group number, we get the valence electrons, and the group oxidation state exhibited is +5. The other oxidation states are -3 and +3. Nitrogen, due to its small size, it has a tendency to get -3 oxidation state, whereas bismuth, because of its large size and poor shielding effect of the d and f orbitals, you find that it is showing inert pair effect and it is exhibiting only +3 in the compounds. However, bismuth is having an exception. Bismuth can form BiF5. Coming to the reactions one by one. First one, reactivity towards hydrogen. The compounds are known as hydrides and the type is EX3. These molecules exist as trigonal pyramidal shape with sp3 hybridization. On checking the stabilities, you find that ammonia will be the most stable one, and it is having a bond angle of 107.8 degree. And when we are checking the other counterparts, you find that this bond angle slightly changes. When we check the stability, ammonia becomes the most stable one and the least stable is BiH3. When we check the sizes of the central atom here, you find that when we move down the group, you find the size of the central atom keeps on increasing. When the sizes are increasing, bond length increases, bond strength decreases, due to which the bond dissociation enthalpy becomes lesser. So it is easy to break the bond. With the result, the thermal stability of the hydrides decreases down the group. When we in other way, we can explain that the reducing nature of the hydrides keeps on increasing down the group. So BiH3 becomes the most powerful reducing agent. On checking the structures of these compounds, you find that there is a lone pair located on the apex of the pyramid, due to which it can act as Lewis bases. So when the size of the central atom is very small, it is having the lone pair located on a smaller area, due to which it can attack an electron deficient center effectively. And so ammonia becomes the most powerful Lewis base among the different hydrides. Next is reactivity towards oxygen. The compounds are known as oxides, the type E2O3 and E2O5. However, nitrogen forms a variety of oxides due to anomalous behavior. When we check the different oxides, you find that the oxides in which the element possess high oxidation state will show more acidic nature than the elements which are having lower oxidation state. However, the acidic nature of the oxide decreases down the group. Reason is the non-metallic character decreases. Non-metal oxides are generally acidic in nature, whereas metal oxides are generally basic in nature. Coming to the next reaction, that is reactivity towards halogens. The compounds are known as halides and it can be of the type EX3 or EX5. Nitrogen, however, does not form pentahalide because it has only S and P orbitals in the valence shell. So maximum of sp3 hybridization is possible. However, the pentahalides are formed by the higher elements, and when we check the pentahalides with that of the trihalides, pentahalides are showing more covalent nature, and that can be explained using Fajan's rule. The only trihalide of nitrogen is NF3, which is highly stable. Coming to the reactivity towards metals. Metals are found to react with group 15 elements. If it is reacting with nitrogen, it forms nitrides. If it reacts with phosphorus, it forms phosphides. With arsenic, it forms arsenide. With antimony, it forms antimonide. And with bismuth, it forms bismuthite. The type is M3N2 provided the metal is divalent. Coming to the molecules in the group. First one is dinitrogen. Nitrogen is a gas and it is commercially prepared by the liquefaction and fractional distillation of air. The liquid air will contain mainly nitrogen and oxygen. You find that nitrogen is having a lower boiling point and so it can be distilled out faster compared to that of oxygen. However, the laboratory preparation of nitrogen can be done in several ways. One is by treating ammonium chloride with sodium nitrite. Another way of getting nitrogen is by thermal decomposition of ammonium dichromate or sodium azide. If we are using sodium azide or barium azide, we get 100% pure nitrogen. Nitrogen is a colorless, odorless, tasteless and non-toxic gas which is less soluble in water. It has low boiling and melting point. However, nitrogen can exist in two isotopic forms, N14 and N15. Nitrogen, it occurs as an inert gas at room temperature. That is because of the triple bond which is highly stable because of high bond dissociation enthalpy. Okay. However, at elevated temperatures, metals will react with nitrogen forming the nitrides and they are generally ionic in nature. Whereas non-metals, when they combine with nitrogen, they form covalent nitrides. One example is ammonia. Uses of nitrogen. You find nitrogen is used in the manufacture of ammonia. It is also used for preparing industrially important chemical like calcium cyanamide. It can also be used as a refrigerant for storing foodstuffs and cryosurgery, that is surgery happening at low temperatures. It can also be used to create inert atmospheres in steel and iron industry. Coming to the next important molecule, that is ammonia. Ammonia, you find it can be prepared from a variety of ammonium compounds. Ammonium chloride, when treated with calcium hydroxide, it will decompose to produce ammonia. Same way, ammonium sulfate, when reacting with an alkali, it produces ammonia. Naturally, ammonia gas is produced when it undergoes decomposition, when urea is moistened, and it will be converted to ammonium carbonate, which decomposes to produce ammonia. This happens in the case of nitrogenous fertilizers. How nitrogen is absorbed by plants. So that is explained in this reaction. Manufacture of ammonia is done by Haber process, and that is done by treating it with nitrogen and hydrogen. It's an exothermic reaction, and you find that it is a reversible reaction, so we can apply Le Chatelier's principle, and accordingly you find that whenever we increase the concentration of the reactants, we get more yield of ammonia. Another way of getting more yield of ammonia is by applying pressure, because you find that at the reactant side we have total of 4 moles, whereas in the product side we have only 2 moles. So on increasing the pressure, we can increase the yield of ammonia. Another way of getting more ammonia is by creating an optimum temperature. The temperature that is favorable is 773 Kelvin, and this happens in the presence of a catalyst like iron oxide, in the presence of potassium oxide and aluminum oxide as promoters. What are the properties of ammonia? Ammonia is a colorless, pungent, toxic gas which has a bleaching effect. You find that it is highly soluble in water, and it is having a pyramidal structure with a bond angle of 107.8 degree. So since it is highly soluble in water, you find that it produces alkaline solution. Ammonia, when it reacts with water, it forms ammonium hydroxide, which is weakly alkaline. It reacts with acids, forming ammonium salts like ammonium chloride and ammonium sulfate. You find that ammonia can also be used for precipitating out different metal oxides. So that is evident when we are doing the qualitative analysis of iron and zinc. Ferric chloride, when it reacts with ammonium hydroxide, it gives the brown precipitate, that is rust Fe2O3 XH2O. Same way, when zinc sulfate is treated with ammonium hydroxide, you get dirty white precipitate, that is zinc hydroxide gets precipitated out. We can also use the ammonia solution for detection of metals in solution. One case is the case with copper or chloride. Okay, so first, when you are taking copper, when copper ions are treated with ammonia solution, that is aqueous ammonia, you get deep blue solution due to the formation of the complex. Silver ions, when it reacts with chloride ions, will form a white precipitate of silver chloride. This silver chloride, when we are adding with some drops of ammonium hydroxide, it disappears, and this happens due to the formation of AgNH3 twice Cl. So that is a complex which is soluble in nature. What are the uses of ammonia? Main use of ammonia is as a refrigerant. It is also important for preparing a variety of fertilizers: ammonium nitrate, ammonium phosphate, ammonium sulfate and urea.